what we're looking at. So before we do that, though, let's recap. So yesterday we talked about there's two different modes inside of Windows. Does anyone remember what those two modes are?
Kernel mode and user mode.
Hello.
Hi.
Hello. Is user mode and kernel mode?
Perfect. Okay, yeah, so sorry, I'm not looking at the comments. So user and kernel. Okay, I like it. What happens in user mode?
User mode only execute the application level
Okay.
services, while the kernel mode is on the core, which is run by administrator side, I think. Just like
Yeah,
that.
I like it. So user mode. And then user does applications and services. And kernel mode does perfect. Okay, so what is a filter driver? What is a filter driver?
Filter driver.
Does anyone remember that from yesterday?
Filter driver. Di ba yun yung ano? Yung nagdadrive ng filter?
Who uses filter drivers?
No one.
Kernel mode.
They're okay? Yes, they live in kernel mode. What are they there for?
They filter the device's IOPS,
That's exactly right.
What call this? Anything else with regards to the hardware.
Yeah, so you said it correctly. They filter I/O. So we saw yesterday an example where Defender would use a filter driver, and maybe different antiviruses use filter drivers. And then the command, so as the I/O goes from the application down to the drive, which lives down here, it comes through and it hits this filter driver. The filter driver scans and then returns back, and then the I/O path continues, or on the way up, scans, comes back, and then continues. It's important to note that the application does not know anything about what's going on down here. All it knows is it makes one call, and it waits for the call to return. But where that call goes, it does not know. So that's good. What command do we use to see what filter drivers are loaded on our machine?
CMD.
Does anyone remember that?
CMD.
FLTMC.
FLTMC shows us the file system filter drivers. We can also see them through MSInfo 32. Perfect. Okay, it's good. What about, we'll try this. What is a thread?
Thread.
What does a thread do as part of a process? What is it responsible for?
Thread. Meron yun. Thread is a process explorer. Is a process.
The one who transmits the task.
Yes, it transmits the task to who?
CPU.
Processor.
The processor. That's it. Exactly. So perfect. So I've got process. I've got the processor, and inside this process, I have threads that can do work. If it's web services, then maybe it's listening for a web request. So I may have a thread that handles a bunch of internet connections. So if this is W3WP, also known as IIS, each one of these threads may handle a different request coming in from the user. So a user may come in and this may be a thread to respond to a user loading a web page. And then another user comes in and this is a thread that responds to that user's web page. I have two different users, two different pages. So how does this one process service different web pages? I have different threads. Maybe another user goes and says, hey, I want to pull up the homepage for Microsoft. Well, they'll hit another thread, and each time these threads do work, it sends it to the processor executes the request for the web page, and then returns the data back. So I have this big process. Inside the process, I can have one thread or I can have many threads, and the threads do different things depending on how the developer created the program. In the case of web services, this is how it will work. In the case of SQL, you would have different threads would handle different queries. So same concept, SQL processor, each thread handles a different SQL query, potentially. So if you have multiple things querying SQL, each one of these threads would be different requests. Or with Active Directory, same thing. So Active Directory uses the LSAS process. Well, how does it handle multiple users logging into the machine at the same time or hitting a domain controller? Each one of these threads may handle different requests. So request from user A, request from user B, request from user C. So there's these threads that do all the work for the process, and they go and look up your credentials and say, yes, you're allowed to log in or not. So LSAS process doesn't do anything. If you need to log into Active Directory, it's the threads inside the process that actually do the work. And that's probably one of the best ways that I can describe what threads are. It allows a process to get work done on the CPU. So the CPU executes instructions from threads. Okay, so let's just say I have high CPU utilization. My CPU is high, it's at 100%. So I go in Task Manager, I see my machine is slow, I see my CPU is at 100%. The first thing I want to do is, I want to figure out what processes are utilizing the CPU. So maybe LSAS is utilizing 90%. And then maybe this down here is, Defender. And it's utilizing 10%. Well, the next thing I want to know, if my machine is slow, I want to know why is LSAS using 90% of the CPU? So my machine's slow, identify, is it a CPU bottleneck? In this case, it is. My CPU is at 100%. And then identify who. In this case, it appears to be LSAS. I can't just kill LSAS. That kills Active Directory. So I need to figure out why is Active Directory so busy. So what do? I look inside of Active Directory at the threads, which I know are the ones doing the work. So I can go and look and say, hey, what's thread A doing? What's thread B doing? What's thread C and thread D doing? And to look and see what a thread is doing, I need to look at its call stack. So a call stack is the set of instructions that the thread is sending to the processor. This is what we saw yesterday when we saw the save and the print and the open. It's the set of instructions that the thread is asking the CPU to do, which is keeping the CPU busy. So this is how all of these connect. LSASS is going to get blamed, but to find out why LSASS is busy, you need to look at the threads. To find out what the threads are doing, you need to look at the call stack. So, process, thread, stack. That is how we troubleshoot CPU-related issues. We look at the process, we look at which thread or threads are busy, and then we look at what those threads are doing. We're going to go into a scenario of this real quick, but does anyone have any questions on this? All right, let's look at a scenario. So this was several years ago. I get a call from a customer that says, we just deployed a new version of TFS. And ever since we deployed that new version, everything for us has been very slow. We've looked at a bunch of things and we can't figure it out. Okay. I didn't know what TFS was. I knew it stood for Team Foundation Server, but I didn't really know what it did. So the customer who I've dealt with before is asking me to come and troubleshoot a TFS issue, an application that I don't know anything about. So instead of saying, no, I don't know anything about it, they said, we don't think it's the server, or I'm sorry, we don't think it's the application. We think maybe it's the server, and the server's being slow. So can you just come look at the server and tell us if you think the server is causing the bottleneck of why the server is so slow? So I said, okay, but before I do that, can you explain to me how TFS works? So here I am, a Microsoft employee, being asked to go troubleshoot an application that I know nothing about, and I'm having to ask the customer to explain to me how the application even works. So why would I even go on this engagement? And this was an on-site engagement. And it's because I feel confident understanding the fundamentals of Windows that I can troubleshoot all different types of problems using logical troubleshooting. So let's take a look at this problem. So before we get started, I'm going to explain to you what was explained to me as far as how TFS works and what it does. So TFS has an application server. It's actually its own server. On TFS, it runs SQL. Clients connect to the TFS box using Visual Studio. It actually let me start over. TFS connects to SQL. Clients connect to TFS. TFS connects to SQL. Okay. These clients are Visual Studio. So Visual Studio is used to develop programs. This is what Microsoft writes Windows in, Visual Studio. So Visual Studio is a developer application that allows you to code applications and write applications. This customer writes their own internal applications. Because they have pretty large applications, including applications that do networking and applications that do finance things, or different, same application, different parts of the application. They have different users that work on different parts of the app. So this user may work on networking, and that's the app. This person may work on UI. This person may work on, data. So they have different users that develop different parts of the code for this project, and we'll call it Project X. So they're all checking into this one program called Project X on this TFS server. All TFS does is it manages people checking in code and checking out code. So this guy goes and says, hey, I want to update the data portion. He updates the data portion. This person says, I want to update the UI portion. And then when they compile it, it ends up with one big program called Project X.exe. So Visual Studio connects to TFS. TFS stores all this data on a back-end SQL database. So developers compile the code, checks it in, checks it out. TFS manages it, but stores all the data on SQL. That's all I know. This is all I know about the problem. And what they're saying is, now when developers go to check in their code, it used to take 20 to 30 seconds, and now it's taking 3 to 5 minutes. So it got a lot slower after they upgraded TFS to a new version. So old version, 20 to 30 seconds. New version, 3 to 5 minutes. All they changed was TFS. They have been working with the Microsoft TFS person, and they can't figure out the issue. They've been working with the Microsoft SQL person, and they can't figure out the issue. So they asked me to come in and look at the environment and to see if I can look at the issue. Okay, 4 areas that I typically like to look at: CPU, memory, disk, and network. When you tell me things are slow, I look at these 4 areas. So for me, I'm going to turn this over to you all. I'm going to start letting you all ask me some questions. So if this problem was in your environment, where you had a similar issue, where you have an application server talk to a backend SQL server, you upgrade the application server, and users start complaining, hey, ever since the upgrade, things have been slow. What type of questions would you have for the user, or what type of data, or what type of things would you look at? So I'll go ahead and let you all kind of ask me. I'll be the customer, and you be the Microsoft engineer, and you all troubleshoot this issue. So what type of questions do you have, and what type of data would you like to see?
I will go to sleep. And then shouting dindo. Shout on dindo.
Have you all ever had a problem like this in your environment?
Sa iPos, madalas yan.
I would like to know the current utilization of the CPU and previous.
Okay, I like it. On which server?
On the how many users are affected are all.
Okay, so good question. One second. So which server do we want to look at CPU, memory, disk, and network?
The TFS.
Okay, but not SQL?
Let's see also the SQL server. Sure.
Okay. All right, look at resources on both servers. The next question was, how many users are affected? So everyone. That's a good question. Every user that checks in files is now having the same problem. So really good question. I'd also like to look at CPU, memory, disk, and network on both servers. What tool do you want to use to look at CPU, memory, disk, and network on the machines?
May ano, ROM, di ba?
What tool would you use?
Task Manager. Task Manager. Hindi ko naman itong mga to. Hindi, tinatanong niya kung anong tools yung gagamitin mo para makita mo yung... Hindi, Task Manager. Ito naman itong mga taga-IT na to.
What tool shows me CPU utilization?
Oh.
Yeah, process.
Task Manager. Yeah.
Oh.
So I'm going to start with Task Manager. It's easy. All right. So I'm gonna remote into the servers.
Magaling pa kami taga-system sa inyo eh.
And I'm going to look at the memory utilization, CPU utilization, disk utilization network of what I can look at in Task Manager. Now, Task Manager is only going to show me so many of those, but we can start with CPU because that's an easy one. Okay, so if I get on the machine, do I just go and look at it when? Do I look at it in the middle of the night, in the middle of the day? Do I look at it all day? I guess, when do I specifically care about the resources on the machine? When do I want to look at the CPU?
When users are using the application.
That's exactly it. So I need to have the user reproduce the problem. So I'm going to look at the resources, but I want to ask the user, how often does it happen? I need to ask them how to reproduce it. Go back to our toilet issue. Hey, the toilet doesn't flush. Okay, every single time? Or just randomly? Or what's the scenario? When does the toilet not flush? It's not flushing every time I go in there and try to flush it, like right now it's happening. If I go and try to do it right now, it's not gonna flush. So I need to understand, is it something that happens all the time that you can easily reproduce? Or is it something that is random and users say, it works most of the time, but then occasionally it's a problem and it doesn't work? The random problems are some of the most difficult ones to troubleshoot because you can't just go and look at it anytime you want to see, hey, what is the CPU doing? What's the memory doing? What's the disk doing? You have to specifically look at those when the problem is occurring. So that makes it very, very challenging. Fortunately for us, ours happens every single time the users go to check in their code. They go to synchronize their code with the TFS server. So I'm able to ask the user, how often does it happen? And he says, every time since the upgrade when I go to check in this file. So that's perfect. So what I'm going to do is I'm going to remote into both of these servers. And while I'm remoted into these servers,
Sino mag-ask
I'm
mamaya?
going to look at CPU
Mamaya.
and
Sa
start
Omipad.
there.
Sino lagay ko? Ikaw na
While
lagay ko sa email.
he is reproducing
Ikaw
the
na.
problem
Ikaw na.
by checking in the file.
Anong gusto nilalagay mga?
Ikaw nga.
Mamaya di.
So,
Baka mga-
should be pretty easy. I say, hey, my car doesn't start.
Ito kasi mga Eddie.
Okay, pop the
Mga
hood,
medyo gabi daw eh.
and I'm going to
gabi?
try to start the
Ikaw lang
car
nandito nun
while
eh.
you're looking under the hood.
Tsaka si Aris.
It's the same concept.
Sige.
I'm not going to sit there and say my car doesn't start. Okay, pop the hood, and me just look at it without you trying to start the car. So I need to look at it while they're reproducing the issue. In this case, it's checking in the files. Okay, so is everyone good so far on this scenario? Because we're about to look at the data. So is everyone good here
Yeah.
on what this looks like? Perfect. Okay. So let's take a look at the data and let's see what we C. So I'm going to screenshot this just in case we need to come back to it. Okay. This is the CPU utilization from the TFS server during the time where he's reporting is slow. Now, this is not Task Manager. This is Process Explorer. So here's Process Explorer. We downloaded this yesterday, and when I click on this graph, this is the same graph. So it shows me CPU. Now, we're going to talk about the different CPUs later today, but this is just showing all of the CPUs. This is showing each one. So this machine, my machine, has 8 processors, 4 cores in one chip. So I can look at all the processors averaged or summed, or I can look at each one. So I can get this view also in Task Manager. I can right click, change graph to logical processors, and it will show me each processor. So this is what I'm looking at on the TFS server. So based on this machine is a VM. It's a virtual machine. It has 8 cores and 8 sockets. Now, prior to me getting here, the TFS support folks from Microsoft said, "Oh, you're running your information on TFS and you're running SQL on VMware. Yeah, that's the problem. You're not supposed to run SQL on VMware." Now, this was several years ago, and it wasn't that you weren't supposed to. They just, from a performance perspective, they said they saw performance issues when they ran SQL on a VMware machine. We know it can be done, and it's not a problem. And I'm sorry, I misspoke. I said this was TFS. This is actually the SQL machine. This is the SQL server. So here's the CPU utilization. Now let's talk about what the green and the red is. The green is how much time the CPU is being used. The red is the portion of the time that is being used down in kernel mode. So what does that mean? So if I go in Task Manager, this is the default Task Manager view. But if I right click, there's an option here that says Show Kernel Times. And it shades in this area of the processor spending its time executing kernel mode instructions. So what is kernel mode instructions? If I go back to here, remember that request that came from Notepad and it transitions its way down to the thumb drive? Well, as it's coming across this line and it's transitioning from user mode to kernel mode, it now transitions down into kernel. So now all these drivers down here that are doing work, this is all now going against kernel time from the CPU. But once that request, remember the request came all the way down here and then we returned it. But we have all these filters that are going to go and do work on this request. Work that's done in this box down here is work that's done in the kernel. Any work that's done up here is user mode. So as the request goes and crosses this threshold to kernel to user, to kernel to user, to kernel to user, it's going to execute on the processor in a different mode. So if I go back and look at Task Manager, this shaded area here is simply saying, this is how much time my processor is spending executing stuff below this line. That's what this shaded area means. This here, the non-shaded area, is how much time I'm spending executing up here. Notepad, making a request to the thumb drive, does work up here, and work happens down here. So that is the difference there. So if I have high kernel time or high shaded time, that means I need to look at maybe a driver or something down in kernel that's busy. If I have, and it looks something like this, and the shaded areas down here, so I have a lot of this is user mode, and this would be something that's happening inside the application. We're going to spend some more time on that later. So I just want to explain to you what these different colors mean. So this is showing me the same data that Task Manager is. It's just presenting it in different colors. Okay, based on this right here, do you think that the problem, and this is on SQL, do you think that the problem is because of a CPU issue on SQL? Do you think the CPU is bottlenecked on SQL machine?
No.
No?
No, yeah. So it would appear that way, that it is not. I would agree with you. What if it looked like this? What if I had green lines, and all of a sudden, one of my processors had a green line up here at the very top? And then the rest of them were like this. Do you think this is a problem? What does this?
I guess there's a problem on.
What does this indicate right here?
Maximum CPU utilization.
Yes, it is one CPU, and one CPU is how much being utilized right here?
100%.
100%. Can that cause a problem?
Yeah.
Yeah. Let's demonstrate this real quick. So I'm gonna do this. I'm gonna demonstrate that very thing right now. Okay, I have a tool here that's gonna generate some work. Okay, it's generating work right now. All right, the tool is called CPU stress. It allows me to activate 4 threads. I have activated 1 thread. Remember, a thread does work. Okay. Looking at this view, you all would probably say there's no performance issue, as would I. Do you all agree with that?
Yes.
There's no performance issue here?
Yes.
Yes.
Yeah.
Okay. What if I change the view to look like this? Do you think there's a performance issue now, looking at it in this view?
Mm-hmm.
Yeah.
So, wait, this view, so look at my utilization, 34%. You say there's no issue. I change my view to this, 30%, and you all say that there's a performance issue?
No.
The CPU has not changed.
Yep.
So would you say this is an issue or not? What if they came in and said, oh, the application is extremely slow right now, completely slow? Would you say that it's a CPU issue based on looking at this data right here?
Yes, they have a problem. It's
The
like-
application is very, very slow,
No.
not able to do a job. Probably not, right?
I guess.
Well, it's still the same utilization. Let's do this. Let's take a look at the application and see what the application is doing. So let's click on the details tab. And the application is using how much CPU?
Oh.
13%? No?
Yeah, 12 to 13%.
Wala na.
Is that a CPU bottleneck? If CPU stress was extremely slow right now, would you say that the problem is because of the CPU? It's only using 12%, so I would say probably none. Would everyone agree with that?
Cleaning lang yun. May...
Okay.
Yeah,
So let's just verify a couple things. CPU stress is using 12 to 13%. The whole entire machine is only using 30%. Whether I'm looking at it at this view or I'm looking at it at this view, it's still 30%. My percentages don't change. Would everyone agree with that?
Yes.
Okay, I'm gonna make
Yeah.
one change. I'm not gonna show you what the change is. And I want to see what you all think. Okay. CPU utilization, 30%. It's the same as before, correct?
Yes.
Details tab, CPU utilization, 12%. The same as before, correct?
Correct.
I didn't change anything with the app, correct? I didn't. If I change the view to this, what do you think now?
Nothing's changed.
It's gonna change na.
There's a problem.
There you go. There is a problem. I would agree. And if you all saw this screen, you would say there's a problem. But if you saw this screen, it doesn't seem to be a problem. Now let's look at the details tab. This has not changed, 12%. This number has not changed, 30%. The application has not changed. So if you look at it in this view, you're saying, nope, there's probably not a problem. But when you look at it this view, there is a problem. But the problem has been there the whole time. I didn't change the application. The application has been slow to respond the whole entire time. Does anyone know what's happening here? And can anyone explain this? Or has anyone seen this before?
Wala,
How do you troubleshoot this? So if I have one CPU that's pegged out like that, has anyone ever seen that before where you have one CPU that's just pegged?
Online sabong lang kasi tinitignan ng mga ano eh. Kaya,
Okay, well now you know to look
tumitingin sa
for it.
graph.
So change your view, right? If you're troubleshooting CPU issues, don't just rely on this view. Change your view, change your view to this. So I have one CPU that's pegged out. So what's happening here? This is, I'm gonna try not to make this confusing, but this does require math. Anyone good at math here? No one?
No, joke.
All right.
Yeah, sure.
This is a mathematical problem. And I'm going to show you why. And for the people that don't like math, you're like, oh, I give up. Okay. What does work on the processor? What does work on a processor?
Time.
Starts with a T.
Time and thread.
The thread.
Right. Perfect. Perfect. Okay. threads do work on a processor. Okay. A thread can only execute on one processor at any given time. I'm going to say that one more time. One thread can only execute on a single processor at any given time. So if I had a single threaded application that only had one thread and it was running slow, does it make sense to go into VMware and add more processors to that VM if I only have a single threaded application? Will adding more vCPUs increase the performance or fix the bottleneck for that application?
Kung one thread lang hindi na kailangan.
Kaya ano talaga yung mga patching ngayon? Yung kuryente sa ba? Pero really?
Hindi, nakakabit na yun eh.
Nakapatch siya ba?
Oo, power na lang.
50-50 shot. You can either say yes or no, and you have a 50-50 chance of being right.
Yun yun
Has anyone ever
nakakabit na
been
hindi pa
asked
tinanggal.
to add more vCPUs to a VMware box? I know there's some VMware people on the call, I think. Has anyone ever asked or been, hey, can you just give me a couple more CPUs?
Yeah.
Yeah. What do you all do? You normally just give them the CPUs? Hey, my app's slow. Can you give me a couple more CPUs? It may speed it up. Is that is that what the request typically is? Hey, my app's slow. Give me more CPUs. So this is the deal. If I have, so here's the app. It has one thread. I have 8 processors. It can only run on one though. Would adding another 8 processors help this situation right here?
No.
No. Because I'm only using one processor. Why? Because I only have one thread.
Oh,
So
single
I have
time lang.
8 processors and one thread. This is where the math comes into play.
Any given time
If
lang.
8 processors equal 100%. So if I have 100% divided by 8 processors, each processor gets how much of that percent? So if my total utilization can be 100% and I have 8 people, what's the total percent for each processor that each processor can have?
12.5.
12.5. So let's do 2 processors. So I have 100%, I have 2 processors. What's the most each processor is going to have? 50%. Okay, so let's talk about threads. So if I have 8 processors, I know that each processor can only use 12.5%, and I know a single thread can only run on one processor. What's the most amount of utilization that thread can ever use on my machine?
12.5.
12.5. So when I click on the details tab, look at the CPU stress. What is it hovering between?
12.
12 and 13, just 12.5%. So I'm going to tile this together and show you this in a different way. So let me show you this in Process Explorer because it'll make it look a little bit easier. All right. Remember, CPU stress is a process. Processes are just simply containers that hold resources. So I want to look at the thread utilization for CPU stress. So I'm going to double click it. And you can see that CPU stress has 6 threads, but only one of them are doing any work. It's thread 7660, and it's doing about 12.26, 12.35% of the CPU. This thread, because I have 8 processors, will only ever be able to use 12.5% of the CPU. A single thread on a machine with 8 processors will only be able to use 1 out of 8 processors, which means it will only be able to use 12.5%. If I want my process to be able to utilize more of the CPU on my machine, my process would need to do what? So I can only use 12.5%. I want to use more than 12.5%. What would my process need to do?
Add more thread. Add ka ng thread.
How do I submit work to processors on a computer? Via threads. So watch this.
Ang tagal
I'm going to go in my process and I'm going to activate a second thread.
Bababa na
Hold
yan.
on. I did something earlier. It is tripping you up.
Use this.
Now, when I check this box, I now have 2 threads that are each using about 12.5% for a total of 25% of the CPU. If I activate another thread, that thread is also going to use 12.5% for 37. Another thread, 12.5. So now I'm at 50% CPU position. For my process to fully utilize all 8 CPUs, I would need 8 threads. So threading, developers, when they create threads, need to take into consideration what type of hardware they're going to be running on. If I have a single threaded application that does all the work on one thread, adding more CPUs to the computer is not going to make it any faster, because you can have 64 processors, but that one thread can only use one processor at any given time. So instead of adding more processors to an application like this, you would be better off adding a faster processor, not more. There's a difference between scaling out, which is adding more processors, and scaling up, which is adding faster processors. In a single threaded application, you can only scale up to make it faster. You can't scale out. Scaling out does you no good unless your application utilizes more threads. It needs to have at least 1 thread per processor to be able to utilize that processor. So, what is happening when I showed you the graph here in Task Manager? So let's kind of recap this. So here is CPU stress has 1 thread that's doing work. It's at 12.5%. You can see in Process Explorer, there's only 1 CPU doing any work. So I'm at 12.5%. I can only use 1 processor. So let's switch to this view. Why is 1 processor not pegged out then? Why is this not happening?
Hindi kasi naka-activate.
Shouldn't 1 processor be pegged out?
Dapat
If I'm
ipa-activate.
maxing out 1 processor at 12.5%, does anyone know what's happening here? Okay, I've got 8 of you in a room, and I have 1 job that I need to have done. And the job's going to take all day. Maybe it's running new cables, but only 1 of you can fit in the space at any given time. I only have 1 spool of cable. How about that? I have 1 spool of cable. There's 8 of you sitting in a room. Only 1 of you can run the cable at any given time because there's only 1 spool of cable. So I have a choice. I can go into that room and say, okay, I'm going to pick 1 of you to run the cable all day. And that's all you're going to do. And the other 7, you're going to sit there and do nothing. Or I can have 1 of you go and run the cable for a few minutes and then come back and give the spool of cable to someone else and have them run it for another couple minutes, and I can have you all trade off. So each one of you runs the cable for a little bit of time, but none of you are ever running the cable at the same time as anyone else. And there's 8 of you in a room. So those are my 2 options. So what's happening right here is I have 1 spool of cable.
Tama.
But
Activate
instead
mo
of
lang iba eh.
having one person run it the entire time, it's running a little bit here, 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 and it's switching between processors very, very quickly. Now, if I want to make sure that this thread only runs on one CPU and not switches from this one to this one to this one to this one, we can go in and set something what we call processor affinity. So if I right-click the process, there's an option here that says set affinity. Right now it says, hey, which processors are allowed to run CPU stress? All of them are. So what I did earlier was I unchecked all of them and just checked one CPU and said, hey, you know what? Just let Albert run CPU, or Albert run CPU stress. Hit OK. So you can see it's still only one job, only one spool of thread. But when I go and look at the processors, now it's not bouncing around from CPU to CPU, it's Albert. He's stuck with running the spool the entire time. I know this is getting very, very confusing. The takeaway for this is just because you don't have a 100% CPU utilization does not mean you do not have a CPU bottleneck. You need to change your graph to logical, and even if you see this view, there's a bottleneck. If you don't see this view, it doesn't mean there's not a bottleneck, because it could be that that job is bouncing from processor to processor to processor. But I'm only running one spool of cable at any given time. To make all of you work, all 8 of you in this room do work, I would need to get 7 more spools of cable to have a total of 8 spools of cable. Then all 8 of you can work. One spool, only one of you works. You all can either take turns or one of you can do it the whole time, but only one of you are going to run one spool of cable. If you want all 8 of you to work, you need to have 8 spools of cable. In this case, the spool of cable is a thread. And who determines how many threads we have? The developer. The developer goes in and says, I want 8 threads, or I want 4 threads, or I want 6 threads. So let's go back to our scenario here. We looked at this SQL box, and we see that none of the processors are spiked. In fact, I'm only at 36%. But this is not enough. You need to look at the thread utilization. So here's SQL Server. Here is the thread section. There's 97 threads, but only one of them is doing work. And it's at that magic number of 12.5 on an 8 processor box, which means Albert is busy running cable as fast as he can. He can't run that cable any faster, but no one else is able to help him. So Albert is extremely busy. He can't go any faster. So even though the whole machine is not pegged out, and I don't have my whole computer pegged, Albert is extremely busy. This one process, this one thread is extremely busy doing something. This concept can be confusing, I get it. However, threading is super important concept to understand, especially with the advanced class. So, I know we're running long. The next thing that I wanted to do is I wanted to see, Albert's busy. There's eight of you in the classroom. In this case, there's actually, yeah, there's 8 of you. Albert's super busy. So the thread that's super busy here is thread ID 3800. It's maxed out. 12.5% is maxed out in this scenario. The next question I have is, what is Albert busy doing? So to figure out why Albert's so busy, I need to find out what instructions he was given and what instructions is he executing on the processor. To do that, I look at the stack. When I look at the stack, Albert says, hey, yeah, I'm supposed to be running this cable. If I scroll down, here are the instructions that SQL is running. The first instruction is at the bottom. We learned that briefly yesterday. So what is SQL doing? It looks like it's starting a thread. It's some type of worker thread. It's processing tasks. It's processing commands. It's executing SQL statements. It's executing a query that gets back rows. It's doing something with the rows. It looks like it's building a profile. And then it's evaluating the data that it got back. And it's matching that data with the string that it has. So SQL seems to be very, very busy, running as fast as it can, doing a SQL query. When they're checking in files to the TFS server. So client checks in a file. Here, that sends data to SQL, and SQL is busy, but it's only busy on one thread. This brings up a lot of questions for me. The first question is, how come SQL is not using more than one thread? Is SQL not smart enough? Is the developer decide, hey, I only want to use one CPU? Why not use all 8 for this SQL query? So that's the first question that I had for the customer. Hey, Mr. Customer, I noticed that SQL is only using one thread. Why isn't it using these other ones? And they told me that they went in and they changed a configuration in SQL called max degree of parallelism, maxdot. And that tells SQL how many threads to use for each query. And they set it to 1. So the customer intentionally went into SQL and tuned it to only be able to use one thread, which only allowed it to use one processor. So you could have added another 8 processors to this thing, and it would not have gotten any faster because of the setting change that they made. So I asked them, why did you set it to only use one processor? And they said, working with Microsoft troubleshooting, they were asked to do that as a troubleshooting step. But the problem existed prior to them doing that change. So what was happening was this. Prior to them setting it to only use one thread, when they checked in a file, all the processors would peg out to 100%. And the machine would become unresponsive. So what they did was they limited SQL, they throttled SQL, so SQL could not take down the entire machine. I'm saying that setting to 1, but that was just a troubleshooting step, that was not the fix. So that told me something else. It said, okay, why is SQL utilizing the machine at 100% by simply just checking in some files? So SQL is clearly very, very, very busy. Whether it's using one CPU or all the CPUs, it's very, very, very busy. So I want to know, what is SQL busy doing? Well, that's when I look at the stack, and that's when I saw it's busy executing a query. So at this point, I feel fairly confident this isn't a network issue, it's not a disk issue, it's not a memory issue, it's not a TFS issue, and it's not a client issue. So it's not this, not this, it's not this. This is a problem with SQL, specifically around CPU. So we can stop troubleshooting TFS, we can stop troubleshooting all this. Now the interesting thing is this, SQL did not get upgraded, nor did the clients. So when we go back to what changed, TFS changed. So that doesn't make sense, because TFS changed, but it's SQL that's broken. We'll come back to that in just a second. So what do? I go and engage a SQL expert, because I don't know SQL, but I pinpointed the problem to, hey, this is a SQL CPU issue. It's running some type of query, and that query is overloading the box. Here's the query. This is what's overloading the CPU. So I asked the customer, I was like, hey, isn't there a way to see what query is utilizing all the CPU? And he said yes, because this tells me it's a query that's utilizing the CPU. It doesn't tell me what query. So the customer runs a command. Is anybody here do SQL? Support SQL? I don't know anything about SQL. But the customer's like, yeah, there's a command I can run in SQL that will tell me what query is utilizing the most CPU. So he runs the command, and the query that's utilizing most of the CPU is a TFS stored procedure. So it is code that came from TFS, which would explain why a change in TFS caused the issue. So TFS changed, but TFS updated some of the code that it runs on SQL, and that TFS store procedure is now causing SQL to run very, very high. So now I've gone from, it could be client, it could be the application server, it could be SQL. I figured out it was SQL, CPU. From there, I investigated what the CPU was doing on SQL, and I realized it was doing a query. Then I looked to see what query it was, and I realized it was actually a query coming from TFS. So at that point, I engaged the Microsoft TFS person, and I told them, hey, this TFS store procedure is causing high CPU. He looked at the specific store procedure and found a bug in the store procedure, and he fixed the bug. So this took them 2 or 3 weeks to troubleshoot, and we figured it out in about 2 or 3 hours. It boiled down to, they had a Microsoft TFS person look at this, they had a Microsoft SQL person look at this, and what was happening was the SQL Microsoft person was saying, hey, it looks like it's a TFS store procedure. So he got the Microsoft TFS person. Well, the Microsoft TFS person said, nope, you're running SQL on VMware, that's the problem. Fix the VMware problem. The Microsoft TFS person didn't want to look at his stored procedure. He was actually very wrong in this case. So once I got on site and was able to show him the specifics of what the CPU was doing around the threads, I finally convinced him, hey, you need to look at this procedure. It is a CPU issue, not a VMware issue. And once he actually looked at the TFS store procedure, that's when he found the bug and was able to correct the bug. This was Microsoft was pointing fingers at each other. The TFS guy was blaming SQL, the SQL guy was blaming TFS. Actually, SQL was blaming TFS, TFS was blaming VMware. So everyone was kind of pointing to the next person who was pointing to the next person, but no one accepted ownership until we went in with data and showed them with data, hey, look, your CPU is pegged, this thread is pegged, and this is what your thread is doing. It's doing this work. And that made them look at their piece of the application. But before this, they wouldn't look at it. And that happens at Microsoft. I'm sure it happens at ABS-CBN. I'm sure it happens all over at different companies. You know it's not your problem. You know it's not Windows, or you know it's not SQL, or you know it's not your SAN, or you know it's not VMware, but you have to prove it's somebody else before they'll listen to you. And understanding the data and understanding how things work behind the scenes can give you the data you need to present to the other team to say, hey, look, I can appreciate you think it's my application or my server or my storage or my VMware box. The data says it's actually your SQL query. But you have to be able to get to that level. And you have to be able to show them data. So we're way over, we're 20 minutes over on break time. This is a fairly complex scenario, but the key to take away is that thing we've been talking about for now 2 days, which is this. If you have high CPU, you need to find out which process, which thread, and then what that thread is doing. Now we've learned